Section 6.3, it's going to talk, it's kind of like either the first or the second one. I think it was the second one. Yeah, we just talked about parallelograms, didn't we? Well, just. It's been 2 weeks since we've done a new lesson. But the last thing we talked about were parallelograms. Does anybody remember what a parallelogram is? Nope. What kind of answer is that? Take a wild guess. It has the word parallel in it, right? Okay. What do I want to do? Shear. Yeah, the opposite sides are parallel. Very good, very good. And there we go. That's our like normal everyday looking parallelogram. All right, that we. But let's review a little bit. So if I said that this was a parallelogram, by the way, I don't know if I gave you the little, yeah, the sign for it. Did I do that?
Yeah.
Did I? Guess what it looks like?
It's a parallelogram.
Yeah, it looks like a little parallelogram. No, it doesn't look like a rectangle. It looks like a parallelogram. So it's a little bit slanted. No, it doesn't look like a rectangle at all. I think it's got 4 sides, but on a rectangle, what's true about a rectangle? We'll talk about that in the next lesson. But what do we know about rectangles? on a rectangle. Yeah, all the angles are 90 degrees on a rectangle, right? That doesn't look 90 degrees, does it? The angles on there? No. So if I wanted to name this, I'll call this A, B, C, D. If I wanted to name this thing right here, I wanted to call it by its name, then how would I name this thing? Parallelogram. Yeah, A, B, C, D. That's a good way to name it. Is that the only way that I can name this parallelogram? No, not at all. Would you say? B, C, D, A. Yes, you could. You could go B, C, D, A. You could go C, D, A, B. You could go D, A, B, C. You got to go around the horn. Here's one way that they don't want you to name it. They don't want you to name it like a crossways like this. So they don't want to go A, then C. All right? If I start at A, then I have to either go A, B, C, D, or I go where? A, D, C, B. Everybody see that? So just don't go across. You can start anywhere at any of these letters as long as you go around the horn. That's what I call it. Anybody hear that before? Around the horn? Probably Cape Horn. You know Cape Horn? Isn't that in South Africa? Right? Don't you learn? Was it Magellan or something like that? I don't know. Maybe not. Magellan, I think, did South America. I don't know. But somebody sailed around Cape Horn. Anybody remember that? Oh, maybe it was Magellan then. I don't know. I should look that stuff up because I forget all that. But anyway, when we say around the horn, that's probably what they're talking about. When you go around like this, okay, we're talking about, I would guess that's where that expression comes from. All right, so this is, let's say it's a parallelogram. By definition, what do we know about a parallelogram? We've already said this once, or somebody said it. Right, okay. Let's say it like this, that both pairs of opposite sides are parallel. Everybody hear that? Everybody good with that? Okay, and that's why. How do we know it's a parallelogram? Because of the definition. That's the definition. But then we learned some other things, didn't we? Let's do each one of these in a different color. We also learned about the lengths of the opposite sides. What did we learn? That they're equal to each other. Okay, that the opposite sides are equal to each other. So AB and DC are equal to each other. AD and BC are equal to each other. All right, then there's something else that we learn about parallelograms. Good, we learned about the opposite angles, didn't we? Let's make that. Yeah, we learned that the opposite angles are congruent to each other. That's right. So we learned that that angle and that angle are equal, and this one here and this one right here are equal to each other. They're opposite angles and they're equal to each other. We also learned something about consecutive interior angles, like this angle right here and this angle right here. They're consecutive angles, aren't they? They're supplementary. And we figured out that they're supplementary because, look, these are parallel lines cut by a transversal, so they are consecutive interior angles, right? We learned that a while back, didn't we? Right? Parallel lines cut by transversal. Yeah, so we knew that was true. What else? Did we do the diagonal thing?
Yeah.
Okay, so let's do that. Let's go blue this time. So diagonals, like if I connected from A to C, the opposite angles, and from D to B, what did we learn 2 weeks ago about the diagonals? If this is a parallelogram, so all this is predicated on this. Here's a big word for you, isn't it? Okay, if this is a parallelogram. So if it's a parallelogram, all this stuff is true. Everybody with me on that? Now I'm saying that for a reason, because we're going to do something a little bit different today, but kind of the same. It's going to look like a rehash of what I just talked about. But this is all, it's given that this is a parallelogram. So if it's given it's a parallelogram, all this stuff has got to be true. With me? What do we know if this is a parallelogram? What do we know about the, we'll call this x. What do we know about the diagonals if this is a parallelogram? That they do what to each other? They bisect each other. That's right. They bisect each other. Okay, they don't just intersect. I mean, it's true that they do intersect, but even more specifically than just intersect each other, because look, these two lines intersect, right? AD and AB, they intersect each other. But this right here, they do something more special than just intersect each other. They bisect each other, which means they do what? They split each other in half, right? Okay, so you make two equal, and we'll do this. We'll just put one little blue arc here, a couple blue here, a couple here. Is that all right? Does that mean that the diagonals are equal to each other? No, they're not. Okay, not necessarily are they equal to each other, the two diagonals, AC and BD. Look, if I measured them out, what do you think AC would be compared to BD? Yeah, it looks like it'd be smaller, doesn't it? And if I took these out of here and measured them and all that kind of stuff, yeah, I'd figure out that they were smaller. That's for another lesson. We'll talk about that sometime this week. We're going to talk about diagonals being equal to each other, but they're not. On just an ordinary, regular old parallelogram, they're not equal to each other, but they do bisect each other. Does that mean they bisect the angles? Look up here. Does that diagonal look like it bisects this angle A? Not at all. This one looks quite a bit smaller than this one, doesn't it? So they don't bisect the angles. But guess what? This week, we're going to learn about a particular type of parallelogram where that is true. But on an ordinary, everyday parallelogram, they do not bisect the angles. We got it? And I think that covers it, doesn't it, for all the stuff that we know about a parallelogram. Now, again, this is important right here for what we're going to talk about today. This is, if this is a parallelogram, then all this stuff is true. Okay? We've been doing this all year. They always give us a statement, right? If P, then Q. What do we do a lot of times? Not all the time, but a lot of times, what do we do after we learn the statement? If P, then Q. Then we reverse it. If what? If Q, then P. What did we call that when we reverse that statement? Call it the converse. Very good. So you guys are learning. All right? That's, well, so whatever. All right, so we call that the converse. So guess what we're going to do here? This says, if this is a parallelogram, then both pairs of opposite sides are parallel to each other. Well, what if I gave you, let me copy this. Let's start again here. What if I gave you this? Now, I didn't tell you that it's a parallelogram. What if I just told you this? Do you think you could say this is a parallelogram now?
No.
Why not?
Because you're not.
Because I don't know anything about the other two sides, do I? But what do you think? Remember what we said before. If it was a parallelogram, then both pairs... You don't even have to write this part down because that's old. If it's a parallelogram, that's the key. If it's a parallelogram, then both pairs of opposite sides are what? Are parallel, right? That's the first thing that we learned. But today, we're learning the converse. So what do you think we're going to learn today? If what? If both pairs of, not just one, but what? If both pairs of opposite sides are parallel, then it's a what? That's a parallelogram. Do you agree? So watch this. Let me see if I can do this. Be real fancy here. So watch what I'm doing. This is how I do the converse. I take the then part and I make it the if part, right? And then I take the original if part, if it's a parallelogram, right? You understand what I'm doing? And I make it the then part. Got it. So if both pairs of opposite sides are parallel, then guess what it is? It's a parallelogram. That's an ugly parallelogram, but you get the idea. All right. But what else do I have to know about this? I have to know that both pairs of opposite sides are parallelogram. So if this was true, if I was given, let me put this on here again. I'm writing a little fast. That's probably the ugliest B you ever saw, isn't it? Let's try it again. A, B. There we go. That's kind of ugly A. I got to slow down. So watch. If line segment AB was parallel to line segment DC, and what else? If AD was parallel to BC, I know what it looks like, but come on, I said what it is. Do you guys make your letters perfect every time? Don't think so. Watch. If AB is parallel to DC and if AD, right, is parallel to BC, then what do you think that I could call this whole thing?
Parallelogram.
Right, then I could call it parallelogram ABCD, couldn't I? All right, remember, I didn't start off knowing it was a parallelogram. I just knew it was some four-sided figure, right? And I didn't know anything about it until we put some given stuff in here. We said that these two are parallel and these two opposite sides are parallel to each other. So if all that stuff's true, then guess what that thing is? It's a parallelogram. Now that I know it's a parallelogram, then I know all that other stuff about it too, don't I? I know the opposite sides are equal to each other. I know the opposite angles are equal to each other. I know the consecutive interior angles are supplementary. I know the diagonals would bisect each other if it had diagonals. Okay? Everybody with me on that? And we could just go through that same thing for all the other theorems that we learned about a parallelogram. So, watch this. What if I knew this? And we'll just name it the same thing. Sorry, don't be yelled at for my weird looking B. C, D. Alright, what if I knew this? Now, right now, do I know that's a parallelogram right now, looking at with all the information there? No, there's really no information given, is there? I got a four-sided figure. I do know it's a quadrilateral, but I don't know that it's a parallelogram yet. But what if I did this? What if I said that side was equal to that side? Now, this is a little different than we did earlier, right? What did we just do just a minute ago? We said that the opposite sides were parallel, but now I'm saying that the opposite sides are what? Equal or congruent, right? If that's all I had, could I say that that thing's a parallelogram? No, because I need what? I need both pairs of opposite sides being equal to each other. And if I knew that and that, could I now say that that's a parallelogram? Absolutely, because these are all converses. These are all converses of the theorems that we learned earlier the other day. Make sense? Isn't it very, very, very similar to what we learned before? But with a slight difference. What we learned before was we were told that this thing is a parallelogram. Then you know all that stuff's true. This time, you don't know it's a parallelogram, but you do know that this particular stuff right here is true. We do know that AB and DC are equal. We know that AD and BC are equal. If we know that stuff right there, then I can say that this is a parallelogram. And if you want to write that down, feel free to do that. So if AB is equal to DC and AD is equal to BC, if all that stuff's true, then we can say that we have parallelogram ABCD. Make sense? All right, so this is all converse. This is all the converse of the statements that we learned before. Let's just do a few more. We got some time. So let's do another one. And it seems like we're just rehashing the old stuff, and we kind of are. And let's call this ABCD again. Might as well be consistent, right? All right. Now, right now, we don't know it's a parallelogram, but what do you think they could tell us about this? They could tell you the angles, right? They could tell you angle A is equal to angle C. They could tell you that angle D is equal to angle B. So if they told you that information right there, let's write that down inside of here. So if angle A equals angle C and angle B is equal to angle D, then, so if those things are equal, what do you think is true about that quadrilateral, that four-sided figure? Then you know it's a parallelogram. Then you know it's a parallelogram, ABCD. Getting the hang of it now, right?
Yeah.
Yeah. All right, let's do some more. Might as well hit all these theorems here.
Did we not?
Not quite. Let's do this one. Oops, sorry, let's try that again. Give myself some more room. There we go. So I'm going to put the diagonals in here. Watch this. We'll call this ABCD. Call this X. All right. What if we knew this? I'm going to write this stuff up here. What if we knew that AX was equal to CX? All right. And we knew that DX is equal to BX. Yep. So watch. That means, right, I've marked the stuff that I knew that was true. Okay, they told you that stuff was true. So if that stuff is true, what did I just do to those diagonals? I did what to them? I bisected, right? I bisected the diagonals, didn't I? So if I bisect the diagonals, guess what's true about that quadrilateral, that four-sided figure? Then, what do you think it is? Then it's a parallelogram. Right, just kind of following the bouncing ball, right? All right. You ever hear that expression? I'm giving you all kinds of old people expressions, aren't I? You should learn these things. What's follow the bouncing ball? What is? Because back in the day, I don't know, probably the 50s or something, there was this guy, Mitch something. I don't know. I'm not really that old. I wasn't around in the 50s, but I've seen shows on TV about it. But they had a show, and it was like a sing-along show, and apparently it was really, when you look at some of the shows today, 30 years, 40 years from now, you'll probably look back on it and say, wow, I can't believe everybody watched that. But it was like Mitch something. I forget his last name. But anyway, it was Singing with Mitch or something like that. I don't know. It was back in the 50s, black and white, before my day. We actually had color TV when I was a kid. All right. So they had Singing with Mitch. And you would sing, and they would have words. And to know when to go to each word, they would have a little ball. You might have seen it maybe on Disney movies and stuff like that. Is it karaoke does that? They put a ball. Yeah, it colors the words, but maybe some karaoke they have a bouncy ball that goes right. So, oh, is that right? Yeah. So that's where they got it from. I think the first people that did it is that Mitch guy. Look it up on YouTube sometime. Maybe you'll see it. I don't know. That'd be interesting. But I know that.
Okay.
So anyway, that's where that expression comes from. I think that's where it comes from. All right. Let's do an example. Is that all right?
Yeah. Example one.
Yeah. You don't think we've ever done an example? Did you say that? Yeah, I think we've done examples. Let's make this look like a parallelogram. Is it?
Figured out how to do it.
Yeah. I've been doing this. Yeah, I've been doing this the whole time.
Couldn't remember how to make the background.
Right. Oh, you know what? We were talking about that in here, and I was doing some searching for different teacher websites and stuff, and I came across this website. I subscribed to him on my Facebook, or what do you call that thing? YouTube. And he actually does that. He changes his background colors for a lot of his lessons. So he's got a purple, a yellow, a pink.
Not yellow,
Is it okay? But anyway, that's what he did.
Cool?
He's a pretty good teacher, actually.
Did Tyler Tarker kid?
No, it's another guy. It's another guy.
I should watch his video, Mr. Hammer.
You should watch it. All right, let's take a look. Yeah,
On my own
absolutely.
time?
Oh, you know what? Almost forgot. We got to put this on hold for a minute. Well, you can keep it there. I'm getting rid of it. Okay. I'll put it back. I'll get back to it. Calm down. I said I forgot to do something. All right. Easy. Huh? You're not talking to me. You looked right at me and talking out in class, so you must be talking to me. A lot? No, I don't want to shear it that much. We'll shear it 20 degrees again. No, I almost forgot this. Watch. There's another theorem, and I forgot all about it until right now. Listen to me now. Watch. Remember how we had to show that both pairs of opposite sides were parallel for it to be a parallelogram? Okay, and then both pairs of opposite sides equal to each other? Well, here's another one. If I could just do this, if I could just show one pair of sides parallel to each other and also equal to each other. So we're not talking about the other two sides. I don't know anything about those other two sides. All I know is that these two right here, the top and the bottom one, they're parallel to each other and they're equal to each other. You follow me? I don't know anything about this side and this side. That's right. If I know this information right here, then I know it's a parallelogram. That's another theorem that we learned, and I completely forgot to mention that until I saw the example. And I was like, "Oh, you got to know that one." I think you got to know that one to do this. Okay? Does that make sense? Okay.
So would you be able to say that's a parallelogram or no?
Yes, you could. This is definitely a parallelogram. Yes, that's one of our theorems. The theorem says if, right, it says if one side, or let's say one pair of sides, we'll put a pair. If one pair of sides are both parallel and equal or congruent, then it's a parallelogram. Okay. Then it's a parallelogram. Okay. So if just one of them, it could have been these two right here, right? It could have been these two that were both parallel and equal to each other, but I just chose the top and the bottom one. So if that's true, then it's a parallelogram. Everybody with me on that? All right. So now let's get back to that example. Look at that. Pretty nice.
Wow, you're snazzy.
I am snazzy. Look at that. All right, so what we're going to do is we're going to figure out if this thing is a parallelogram or not. Okay, this is the information that they give us, and we need to figure out if this thing is a parallelogram. Remember, we don't know it's a parallelogram right now. We don't know that the opposite sides are equal or anything like that. Okay? And let me just see something. Yep, okay. Shoot. Let's go back to this. I missed another one. I'm missing all kinds of them.
Really?
No, that's all right. You can put it on this one where the angles were equal to each other. We'll go back to this one. So, because it's the same basic picture. There we go. What else do we know? The opposite angles are equal, but we also knew something else about the angles. If what? If angle A and what else? Angle D are, yeah, let's give it a better word than that, are supplementary, and what else? If A and D are supplementary,
Then A, B.
let me see how we want to say that. Yeah, if A and D are supplementary, and D and C, let's do that. D and C are supplementary. Okay, then, guess what? And then it's a parallelogram. Okay? Let me just see that theorem real quick. Because hold on, let me pause this. Actually, I don't think that's a theorem, to tell you the truth. But, you know, it probably doesn't have to be a theorem. Let's think about this for a second. And it's because of this example that I'm saying all this stuff. Let's just keep that. Let's get rid of all this. Get rid of all that. And then I gotta click on that. Get rid of that. Get rid of that. Okay. But let's think about this for a second. If these two are supplementary to each other, so if angle A and angle D were supplementary to each other, this would be the lost my mind a little bit here. Two parallel lines cut by a transversal. If this was a transversal right here, and these two were supplementary, what would be true about A, B, and D, C if A and D were supplementary?
Equal.
No, not equal.
Parallel.
They got to be parallel to each other. They got to be parallel, right? Would you agree?
Yep.
Now look at this. What if D and C were supplementary to each other? Then what would be true? This is a transversal, so what must be true about this? Then they're parallel. Everybody see that? So it's not technically a theorem, but we could kind of make up our own theorem, couldn't we? If, you know, I don't know how you would say it, but if these two are supplementary and these two are supplementary, then that must mean these are parallel, these are parallel. So if they're both pairs of opposite sides are parallel, then guess what this thing is? It's a parallelogram, isn't it? Make sense? All right. With all that said, let's go back to our example. Good thing we did the example because I forgot a few things here. So let's take a look. Look at this. This is 100 degrees, right? And this is 80 degrees. So what does that tell you? And we already know that these two sides are equal to each other. But what does the 100 and the 80 tell you? They're supplementary, which means what? If these two are supplementary, this would be your transversal right here, wouldn't it? So that must mean what? FG is parallel to JH. Very good. Well, we didn't know it was a parallelogram to begin with. Remember that? We didn't know it was a parallelogram, so we didn't know at the beginning that they were parallel. But by looking at this angle right here and this angle right here and knowing that they were supplementary, that means that this side and this side are parallel to each other. So check it out. Both pair, or this one pair of opposite sides is both parallel and equal, right? So what must be true about this whole entire parallel, or this whole entire quadrilateral? It must be a parallelogram. Make sense? Okay. Well, we don't really have a theorem that says that if the angles are supplementary and the lines are, or whatever, or equal or whatever. But we do know, since these two are supplementary to each other, we have two lines cut by a transversal. These are consecutive interior angles, right? So if the consecutive interior angles are supplementary, then those two lines must be parallel to each other. So we know that now they're parallel to each other. We already knew from the beginning that they were equal to each other. So if they're parallel and equal, if one set is parallel and equal, then you know it's a parallelogram. Okay? Does that make sense at all? What if I did this? Just popped in my head, so might as well say it. Like 30. Is that better?
You like 80.
How about 30? You didn't tell me. All right, let's take a look at this one. What if I gave you that this side was parallel to this side, and this side was equal to this side? Is that a parallelogram?
No.
Wait, yeah, because if that thing's the transversal, then it wouldn't be the same as the other ones.
Yeah, what did she say?
Could we draw it? Could we draw something like this, where this side right here is parallel to this side, and this side is equal to this side, but it's not a parallelogram? But it's not a parallelogram. Let's think about it for a second. I gotta resume, sorry. So what I did is I made this length equal to this length right here, correct?
Yeah.
So the length is exactly the same, but watch this. What if I put it right there? Okay, and
What did she say?
watch this. Oops, missed it just a little bit. I ran out of room, sorry. Let me try it again. There we go. That's pretty close right there. Now look at that. Is this whole thing now a parallelogram? You still have two equal things. You still have two equal sides, right? And two parallel sides right here, but is that a parallelogram now? No, it's not. So can you just have one pair and then parallel and the other pair equal to each other? No. You must have one pair parallel and the same pair equal to each other. So that was good that we did that, don't you think? All right. And that was good, Allie, because it took me a while to find it too. And you found it. And so thanks. All right. We good with that? Alrighty. Let's do another example. We got a couple minutes here. We got some time.
We do examples for you.
I'm just gonna do. I just found a problem here. What do you want to? What do you want to shear it to?
80.
50. 80.
80's too much. 80.
Well,
80
let's see
be-
what 80 looks like.
Okay. It would be that. Wow, that's crazy looking. Now we'll just go back to 30.
No, do
You
you?
do 100, which would be a 30.
Let's go 30, 27. How about
What?
that? But let's have some fun with it, and we'll rotate it. Isn't that fun? Woo!
Yes.
Oh yeah, we're rotating so much.
We're having fun now. And we'll rotate. We'll reflect it. Oh my gosh. We're going crazy. And I'm going to rotate it some more.
Why?
Just because I want it to kind of look like the one in the book, that's all.
Which number is it?
I think I sheared it a little too much, but that's okay.
No, it's good.
So let's do this. All that silliness just for this. Watch. This is 5x minus 2. This is kind of the stuff you're going to be doing. And then 3x plus 4. All right, here's the question. It says, find x and y so that each quadrilateral is a parallelogram. So we want to find what x should equal and what y should equal in order to make this thing right here a parallelogram. So we don't know it's a parallelogram yet, though, do we? But it's kind of the same thing. Yeah, exactly. You just set them equal. Because watch, if this and this are equal to each other and this were equal to each other, then it would be a parallelogram, correct? And that's all you do. It's not difficult. It's very easy. I never said it was hard, but that's what you do. Set these equal to each other, solve for x. Set these equal to each other and solve for x. No big deal.
Any like example for or stuff we can say.
I don't know. Let's see what your homework is. All right. It's section 6.3. And it's pages 414, 415, and I broke it up into two chunks, 9 to 14 and 18 to 27. There it is. 9 to 14, 18 to 27. Look, I have not given you homework in 2 weeks. Say it. 2 weeks.
Yeah, well,
So don't complain.
We only had your
I know, we had midterms and we reviewed for the midterms, but I'm just saying, all right? So enjoy it.